of this year, it's my pleasure to announce this keynote by Professor Jie Tang. He's full professor and associate chair of the Department of Computer Science and Technology of Tsinghua University. He also obtained his PhD from there 15 years ago. In the meantime, he has been visiting scholar at Cornell with Hopcroft and Kleinberg, and he was at Karl Leuven at the University of Illinois with Xiaowei Han and many others. And in the meantime, he has become a very prominent figure in the field, worked numerous publications. On his website, you read 200 publications, but that only shows how modest and busy he is. As of today, I find 450, which is extremely impressive. And he made numerous contributions to fields like social network analysis, in general network analysis, graph mining, machine learning on graphs, knowledge graphs, citation graphs. And in today's talk, he will be talking about his latest work on language models, amongst others, as I understand it, a language model that essentially unites the strength of existing language models and surpasses them, and I think it's going even further than that. So without further ado, I would like to hand over to Yi, and I'm really looking forward to this talk. Please.
Okay, thank you very much thank you for the introduction, and also thank you for the conference for inviting me to be here. I'm quite honored to be here to introduce our work, WuDao. So WuDao actually is the name of this project. So our final goal actually is to pre-train the world. So that's a title. So the slides actually used here will be available very soon on my homepage. So if you're interested, you can Google my name, and or probably you can scan the barcode and to find my homepage and download the slide. But it's not available now because there is some kind of internet problem, and I cannot upload the slides now. But anyway, it will be soon available. And so I am actually affiliated with Tsinghua University. So I graduated in 2006, and after that, I just stayed in Tsinghua and worked there for almost 15 years. And 2 years ago, I actually also partly joined the BAAI. It's a Beijing Academy of Artificial Intelligence, with the goal of build some kind of you could say a platform for AI development in Beijing. So finally, this is actually at the beginning, it's a virtual academy. So we just actually invited people from different universities and also different, for example, companies, and working here. We want to build some kind of a big things. For example, here, our goal actually is to build some kind of a big model with all the data and with some kind of a supercomputer or something like that. So that's the basic idea. So of course, the background of this research actually is that, the AI, we are actually facing the third generation of AI. We know that the first generation of AI is symbolic. Around that time, probably 50 years ago, or maybe 60 years ago. So the goal actually is to design, or you could say define some kind of representation language to represent all the things in the world, so that the computer can process all the data or all the things automatically. So, but the basic idea around that time actually is to find, or you could say design some kind of language to represent all the different logic or knowledge or something like that. Or the second generation, you could say, is a big data era, because around this time, the goal actually is to build some kind of machine learning model, for example, like a deep learning model to recognize, for example, something from image like face recognition, or recognize some kind of terms from text. So that's the second generation. And now we are facing the third generation. The idea actually is that we have to simulate some kind of like a computer. We build some kind of computer which is almost similar like a human being, so which can do like a sense, even we cannot distinguish it from the human being. So of course you could say, oh, that's actually the Turing test. So well, of course we hope that in this generation, we call it the cognition AI. We hope that in this generation we could build some kind of like AI algorithm or AI machine which can do some things like even more like human being. Okay, so the idea technical wise, of course, we hope that we can combine the symbolic information and also the big data together. So because simply use the big data, probably we cannot deal with all these things like logical or something like that. But simply with the symbolic, we cannot do the big data sense. So that's the idea we call it. We want to combine data and the knowledge together. Okay. So GPT-3 actually is a big thing. So last year we know that actually OpenAI released the GPT-3 with the parameter almost 107.75 billion. So it's just simply so huge. And at the beginning of this year, Google, of course, released another one, that's the Switch Transformer. So such kind of big model, so actually offers big potential for AI. For example, the left bottom example. So if you talk with the GPT-3, like you can ask who are you, and probably GPT-3 will answer you, I'm an AI created by OpenAI, and how can I help you today? And you could talk anything, and the machine can just talk to you. I mean, it can generate any kind of language, any kind of text, and just chat with you. And the performance actually is so good. And the right side actually is another example. So you can input just some kind of text, for example, generating image by text. And of course, you can input any kind of text. And then the machine, the diary, is also released by GPT-3 this year in January. It can generate some kind of picture based on your text. So it's just so amazing. So this actually gives us some kind of like inspiration that how to build some kind of like a cognition AI in the future. So we just based on this background, we build WuDao. So WuDao is you could say WuDao is another pre-training model comparing with GPT-3 or comparing with DALL-E. So for example, you can ask any question to WuDao. So saying, so which moment did you want to live in forever? Oh, and also, of course, you can specify any kind of like a user personality. And then WuDao can generate all the text character by character. Okay, for example, in an instance, I recall the second year of high school, and that afternoon, and all the words and all the character and even the punctuation of period have simply have been generated by the WuDao model. So that's the first example. And the most exciting thing actually is that we can even use the same model to do the poem. So here is another demo. But of course, sorry, it's in Chinese. I mean, the demo is in Chinese. And if you're interested, you can scan the barcode and to play with this. We call it the Turing test because over there is some kind of poem generated by the machine, and also some kind of poem, writing by the human being, the real human being. Okay, for example, if you input some kind of like a big coin, so okay, the machine will generate a poem. So you see, the right side is a poem generated by a machine, and the left side actually is the Chinese translation. So it's just I translated because this machine actually generated a Chinese poem, and then we translated it into the English. Okay, and also here's another one. The Turing test actually is that we give you some example. So for example, if you input some kind of title, and the machine will generate some kind of poem, but we ask you to select which one is written by human being and which one is used by the machine. So this is totally in Chinese. I'm sorry for some foreign audience, but anyway, this is a demo, so it's quite interesting. So another one is just more general. It's actually draw the pictures. So if you input some kind of title, for example, here the young polar bear and swim through ice water, and then this picture actually, is just automatically generated by the machine. This picture is generated by the machine. You can input any kind of like a style, for example, like a cartoon style, or some kind of like a national style, or even something like that. So you simply input some kind of text with the style, and then the machine just draw this picture. You see, some picture probably there is some kind of still some kind of like maybe not so perfect, but for almost other picture you just see it's quite impressive. For example, you see the red bus is driving on the road. So you said we just automatically generate this bus and also the road here. So the most exciting thing is that we actually do not use any labeled data. So all the data actually has been inputted, fed into the machine with image and also text. And we just input all the text and the image and also all the things into the machine. That's why we call it the title is Pretraining the World. And then the machine automatically learns the pattern. And then for any kind of words, you just any kind of word, and then the machine can generate a picture. Okay, so there is actually a demo. So, but again, I have to say sorry because the demo is again in Chinese. So, like if you input like a golden bridge, and then so the machine will generate such kind of like a picture. And also you can input any kind of person name, and the machine will generate some kind of picture of the person. And also you can generate. You can input the text, for example, a cat with the sunglasses, and then the machine will generate a cat really with the sunglasses. Also, you could say a person actually ride a bicycle, just fly into the moon, and then the machine will generate such kind of picture. So you see, there's a person and ride a bicycle and fly into the moon. So that's a demo. And we actually, we did some kind of comparison with DALL-E. So just now I mentioned that actually OpenAI also released DALL-E in January. So we did some comparison with them. For example, here is some kind of example, like a blind is on the phone. Here the picture is totally generated by the machine, pixel by pixel. And also you could type some kind of, a tiger is playing football. You see, here's the tiger. It's quite a high resolution. But the bug is that actually the tiger, the ear of the tiger is missing. So that's a generation bug. But anyway, so if you are interested, you could also input in one more word. For example, a tiger is playing a football, but it's a cartoon. So you say, okay, this picture, the style is quite totally different. It's quite different from this one. This is cartoon style, and this is the real style. So, okay, so we could support different styles. So this actually is not just for fun. It's not just for a demo. So actually, together with Alibaba Damo Academy, so we actually designed some kind of AI-aided design. So which means that, okay, all the normal user, for example, a customer can input any kind of word and then generate such kind of design. And then the user can actually ask for example, the industry, for example, the industry to design this one and also to produce this one, and then automatically generate all the different things. So that's probably the future of the industry, maybe the industry 5.0 or something like that. But anyway, we give them some kind of AI-based one, give them some kind of design mechanism, and also the new personalized design and personalized maybe in the future of such kind of like such kind of things. So we have the Turing test. So if you go to this website and you will say the left side is 8 Turing tests, the first one is Tang poem. So it's a poem from the Tang Dynasty. And then the second one is Song poem, which means the poem is from the Song Dynasty. And here is a couplet and the caption, question answer, writing. Writing means that, okay, the machine can automatically write some kind of paragraph and compare with some kind of like a journalist or something like that. So, and also drawing, you input any kind of text or words, and the machine can just automatically generate a picture. And image caption is that you give a picture, and the machine will automatically generate a caption. And of course, here, because it's a Turing test, and we want to compare the human provided image caption and also the machine generated image caption. And then if you compare with them, if you selected the right answer by the human being, you win. But if you fail and you selected the answer generated by the machine, you fail. So we basically want to invite everyone to test this machine and to see how likely we can pass, the machine can pass the Turing test. So that's the general idea. Okay. So the backend, behind all the things is WuDao. So now it's WuDao 2.0. It's almost I have to say it's actually the largest one in the world because it has the 1.75 trillion parameter, almost 10 times larger than GPT-3. So how can we build this? This just you could say is a huge model. Okay, how can we do that? So let's first say this WuDao 2.0. It actually has 1.7 trillion parameters, and it actually has both text and images. So we feed some kind of text, but also we feed all the images. It has been trained on a supercomputer. This computer actually is so huge, just big. It actually has almost 100,000 V100 GPU, almost like that, comparable with that. But it's of course it's a supercomputer with CPU. It's not GPU, but it's comparable with 100,000 V100 GPU. So it's we use all the data is bilingual text, 4.9 text with the text and also image. So we train it on a supercomputer. We build all the software, the underlying software. We just write all the code, and also on the top of that we develop the training framework, and also on the top of that we just design our own you could say pre-training algorithms. So we use all the software and also you could say operation system, and then we have the training framework and also the algorithm and all the different things. We just redesign all the operators, and also we redesign the efficient communication strategy between the different machines, because there are so many cores in that machine. You have to design some kind of balance strategy and also some other strategy. For example, the different experts, like the MOE, like mixture expertise is very important for design such kind of like a huge model, because we have to make it sparse, right? Okay, we have our own algorithm that is fast MOE, because this algorithm makes it possible to design some kind of like a huge model like the 1.775. So with all the different things, you could say we have the supercomputer, and also we have a large data, and also we have a new algorithm, and then we could design such kind of model. But probably the question from you is that, okay, it's easy. If I have a machine, I can do that as well. If I have the data, I can do that. I can also do that as well. So, but what is the algorithm? So probably the question is somehow like that. So we design some kind of new algorithm to do that. So this here is the underlying, you could say, a fundamental algorithm for the pre-training. We call it a general pre-training framework. So basically, here is the paper, and if you're interested, you can scan. You can find this paper. So the basic idea is that we just convert all the tasks. You could say the NLP task or natural language processing task, but actually it's not simply like a natural language processing, because we have the image, right? So you could say that we have all the data there, and we just convert all the tasks into the generation as a generation task. How can we do that? So let's firstly go through, or you could say, let's firstly go back to take a look at all the pre-training model. So here is the pre-training model. You could say the different types of the pre-training model. So the first one is the autoregressive model. So somehow like a GPT, GPT-2 or GPT-3. That's the first one. But the GPT basically is good at, for example, unconditional generation. For example, if you give them some kind of like text, for example, just a good morning or something like that, and then GPT can generate any kind of text. We call it unconditional generation. And the second category of such kind of pre-training model is the auto-encoding model. For example, Bert, Robota, or Albert. So such kind of model actually is good at natural language understanding. So which means that, okay, if you build some kind of BERT model, basically you can use such kind of model to do the like a blank filling. So for example, you can mask some kind of text and ask the model to predict the missing text. Or you could use such kind of model for example, like a sentiment analysis or classification or something like that. So that kind of model actually is good at that. And the third type of the model is the encoder and the decoder model. It's like a mask and BAT and T5 or something like that. Such kind of model actually is good at like a dialogue, like a question answer or something like that. But none of them actually is good at all the differences. So our goal is to build some kind of more general model, because the model actually, what we want to do actually is to build some kind of huge model, like a 1.75. You cannot say that, okay, I will build one autoregressive model, 1.5 trillion model for that, and another 1.75 model for that, and another one for that. No, it's too expensive. So our goal is that we hope that we can build some kind of more general model. We call it a general language model, and which can do all the differences: natural language understanding, conditional generation, and unconditional generation. Sorry. So the idea is that, okay, so for classification, so if you say, for example, if we want to do some kind of sentiment analysis or classification, like for the input X, so if we want to predict it's positive or negative, so we simply convert it into a generation task. So for example, here is still the text, but for the text, we actually combine with something like it's really and mask. Mask is what we want to fill in. So another one actually is directly generation. For example, here is again the text, the input, and we want to generate something like we call it a mask, and here is the output. So you see that with such kind of conversion, all the different tasks simply just has been unified into the generation. For example, here is the classification. We generated the output Y, that is positive or negative. But here is for the generation task, the general generation task. We just simply generated the output. So that's a general idea. And then how can we build such kind of model? To build a model is still a pre-training framework. So we still use the mask idea. So the mask idea is that we sample, for example, in the middle, we sample like 15% of the text as the generation objective. And also we sample you could say 50% to 100% in the end as the generation objective. And then in this way, for example, here's the example. For example, we have X1, X2, X6. So if we sample like the X3 in the middle, and then we sample X5, X6 in the end, and then we have the two parts. The part A is we have X1, X2 mask, X4 mask, and part B we have the text in the end and the text in the middle. And finally, we combine all the different things, and we have the generation task, right? And then we train a transformer model, and we learn some kind of self-attention mask. And finally, all the differences actually has been converted into autoregressive blank filling. So that's we simply want to predict the missing, you could say, the masked text or the masked text in the end. So that's the idea. Okay, so let's say the performance. The performance is that, okay, for example, for the understanding task, and for example, classification, our performance actually is better than Bert, T5, and Robota. So you said, okay, so for this kind of task, our performance is already very good. And another one is that we could apply it to unconditional generation or conditional generation. You could say that the performance actually, again, is better than such kind of generation, like math and also some other kind of GPT-based model. So the performance is quite good, right? So the most important thing is that we only use one model and to do all the different things. So that's the most exciting thing. Okay, so another thing is that, okay, we want to explore how to apply such kind of model to different domains, or you could say different tasks. Because before, actually, we would say if we have some kind of big model like the GPT or such kind of WuDao, so if we want to apply to some kind of domain task, we have to do some kind of fine tune. But recent study shows that, okay, actually probability is another way, and is another good idea actually to help such kind of like a task. But in probability, before the handwriting probability, the performance of course is very good. For example, the first one is handwriting probability. The performance is quite good. But it is very sensitive to the data noise, or it cannot be easily applied to some kind of new data because it's too easy to overfit into the tested data, right? And some other idea is to learn some kind of discrete probability. But again, this one is very sensitive to the data noise. For example, if there is some kind of noise in the data, the performance is always is bad. Okay, so we propose a new idea that is p-tuning, because with the p-tuning we actually do not need any fine tune. We directly use the p-tuning, and then we can apply the model to some kind of new data. We call it a continuous probability. So the difference of the continuous probability from the traditional discrete probability is somehow like this. Before, for example, given a text, if we use a discrete probability, basically is to learn some kind of probability, and then if such kind of probability could extract some kind of information from the text, and then this is a good, and then we give it a reward, right? But now the idea is not like that. We propose a continuous probability, and here for the probability, we actually build some kind of encoding, which means that the probability actually has a continuous space. All the probability actually has been embedded into some kind of embedding space, and then if the embedded probability has been matched to some kind of text, and then we use a back propagation to give some kind of weight update, or if it is wrong, we give another update of this one. So in this way, we actually give some kind of new idea of this problem generation. And the most important thing is that such kind of problem generation, it can easily capture the noise and also tolerate the noise. So let's say the results. So here is the performance on Llama. Llama is it's a knowledge extraction task. We say that our performance with the p-tuning. For example, we apply p-tuning to Bert, not WuDao. We simply apply it to Bert. You see that the Bert performance is much better than before. And also we can apply it to any other model. The performance, again, is much better than fine-tune, and also some other probability idea. And also we apply it to like a few short natural language understanding. So it's again the few short extraction task. You see that the p-tuning actually again is much better than some other algorithm. So which means actually we give a new idea of how to use the big model. because the big model, if you cannot easily use the big model, actually is very, very tough. It's very expensive. Even fine tune, if you apply the big model to some kind of domain task and fine tune the model, actually is also very expensive. But now with the P-tuning, we can easily apply the big model to some kind of like a new task. And another exciting result here is that, okay, before we always believe that, okay, fine tune for example, for NLU, like a natural language understanding, we always believe that Bert is better than GPT. But here you said, okay, with the help of P-tuning, you say we can even make the GPT better than Bert. So that's quite impressive because this actually gives us some kind of different idea, different point of view to look at the different pre-trained model like GPT and Bert, right? So the last thing, I mean, algorithm-wise, the last thing is how to make the model can generate a better, for example, text or image. So that's another paper. We actually have the paper published at KDD. So it's quite impressive because you know that before, if we say, okay, which moment do you want to live in forever? So that's a question. That's an example actually I showed before. So we call it uncontrollable problem-based generation. Why? Because the text, generated text is quite good, of course. But you see that the relatedness is very weak, which means the generated text actually is somehow weakly related to the question, right? So the idea here is that, okay, we resort to the human being, how human being generates some kind of text. When human being generates some kind of text, for example, if we write the first sentence, we always consider if the first sentence is relevant to the question, right? And if we continue to write the second sentence, again, we will say, well, okay, how about the two sentences? Are they really related to the question or not? So for every sentence, the human being will think if it is related or not. So that's the idea here. We call it inverse problem. Okay. So for example, okay, if we give some kind of like an initial problem, that we could say that's actually a title, something like a title, and then we generate the first sentence. And here is the poem, actually, the example. So if you say you give a New York as a title, and then we generate the first sentence, and then for the second sentence, if we generate it, we will use the two sentences to reversely to generate a title. I mean, at the beginning, it's a title to generate the first sentence, second sentence, but here we use the inverse problem. So for every sentence, we will use it to inversely generate a title. So that's a basic idea. And then we use beam search to select it. I mean, for all the following just steps, every steps we just generate several candidates, and then we use some probability scoring every pass and finally select the best pass. So that's the idea. So here is some kind of example. For example, if we input the title, and here is the output, and then we just calculate the likelihood. We calculated the log likelihood, and here is the score for the title for the first sentence, right? And so we actually use this idea to inverse the problem with the title to improve the relatedness, just like the human being. Okay, so here is with this idea. Here is some kind of final result. We call it the final generated poem or for the New York, and here is some kind of evaluation by for example, for the QA, because it's not just for the poem writing. Actually, it can be applied to question answer. So we compare with some other model. For example, some other model could be designed based on as well also the pre-training model or some other problem of the baseline. You see our performance is much better. But of course, to compare with the human being, I mean the poet, so you said it still underperforms something. And also here is the poem, and also compare with some other model. For example, 九歌. 九歌 is actually the poem is specifically trained on some kind of poems, all the poems in China. So you see that again, So in terms of innovation and also the overall, our performance is better. But of course, in terms of the format, it's still better because it is trained on all the poems in China. So here is the Turing test. We designed some kind of demo and invited all the people to just play with this Turing test. And finally, up to the paper has been accepted and been published. So the almost half, 45% of the people, of the users cannot recognize if this one is, if a poem has been generated by a human being or by a real person. So that's a basic idea. So here we basically introduce our work on the WuDao. So it's actually quite an interesting idea. And our goal, of course, is to pre-train the world, I mean, all the data and all the images. And hopefully we can build some kind of foundation model, a unified model for all the different sensors. For the demo, we only have Chinese, but for the model itself, we have a purely English one. It's 10 billion. So if you want to use that English one, you can go to our website and you can download the English one, and you can fine tune it to any kind of task at your hand. So anyway, thank you. If you're interested, you can text the email to me or ask any kind of question. Thank you.
Okay, excellent. Thank you so much for this great and insightful talk. So it's time for questions. So please feel free to post questions in the Whova. So there's, as you know, there's a special functionality in Whova where you can post questions, but you can also raise your hand here. Okay. So while we are still waiting for questions on the Whova, maybe I should just get it started. So you're, I'm sure, well aware of methods that inject common sense knowledge and everyday knowledge and world knowledge into those models, language models. So is this an option for you as well? Is this something you don't have to do anymore because you're so close in the performance to human performance? So how would you comment on that?
Yeah, that's quite a good question. Actually, it's something we didn't do, but we are, yeah, we didn't do, but we are still want to do. So that's to combine the knowledge into the pre-trained model, because so far, actually, the model has been purely built on the text and the image. But we hope that in the future, we could fit some kind of knowledge like a Wikipedia and also some other knowledge graph into such kind of model. But you know, actually, there is some kind of like a debate on this, because one thing is that we found for a small data, if we fit some kind of knowledge graph like Wikipedia, we can significantly improve the performance of the pre-trained model. For example, we apply it to some other task, so the performance can be improved. But if we continue to increase the size of the data, I mean, we have huge data, right? All the data. So you will see that the improvement actually is very limited with the knowledge graph. So that's something that's a reason actually we didn't intensively work on that. But another idea, I believe it definitely works. The idea is that, okay, probably after training such kind of big model, we apply the big model to some kind of domain task, and then we can just use some kind of knowledge graph to help do the reasoning or something based on the pre-training model. Maybe that one would be much more useful. Okay.
I see. Thanks for the answer. I don't see any questions yet on the Q&A. Oh, there are two. Okay. Have you plans regarding audio pre-training?
Yeah, that's a good question. So for the audio, definitely this is quite interesting. But there are two ideas. The first one is that, okay, so for the audio, we simply convert it into text, and then we consider it as a text for the pre-training. So that's the answer one. But another answer actually is that we are also working on the video. We actually want to combine all the video together into the pre-training model. Probably in the end of this year, we will do that. And hopefully, in the end, we could have some kind of, the user can input text, and then the machine can return you some kind of video. So that's another idea. But we are still working on that, yeah.
Excellent. So I have another question here on the Q&A of Huwa. Everybody is welcome, please, to participate. One question asked is, thank you, first of all, thank you for the great talk. Can you comment on limitations of the model? What is it not able to do? So what are the weaknesses, weak spots, things you intend to improve on still?
Okay, that's a good question. That's quite good. Okay, so I would say, yeah, probably I use this example, okay? So there are two limitations so far. Okay, the first one is that since the model is so huge, like you say the model actually is 1.75 trillion parameters. So if a normal user or even a company want to use such kind of model, so actually it's very expensive, or you could say it's very inefficient. Okay, so probably you have to run like several minutes to have such kind of answer. So that's the first limitation. We are working on that to design some kind of more efficient inference algorithms, or just try to distill such kind of model to some kind of smaller model so that everyone can use that one. But anyway, that is the first limitation. Well, the second one actually is that, okay, so you see the text generated here is very fluent and very good, looks good, but actually it's not the fact. I mean, the generated answer probably will be wrong. Okay, so how to generate some kind of correct answer? So that is a big challenge. So we are also working on that. So we want to guarantee the generated text is just like you could say that is just correct. So that's another important thing. Yeah.
Well, that's also quite related to a question that I also see in the chat. It says, okay, the pre-training approach encodes knowledge in model weights. This makes it difficult to update world knowledge over time. How about, these knowledge updates? Wouldn't an information retrieval and data set model work better and more transparently? I'm not sure I understand this question completely, but updates is the question. It's, I think, a little bit related to what you have just said. Yeah.
So yeah, that's another good question. So yeah, we are working on that. So we have a sub team because we actually have as a big team working on this project. We have almost 100 person working on this WuDao project, and we have a very small sub team. They are working on, they call it lifelong learning for such kind of pre-training model. So the idea is that, okay, we can first build some kind of small pre-training model, and again we use some kind of new data to build another new pre-training model, and finally the two models can be combined together. They can internally link together. So in this way, we actually, you could say from the outside, you could say we actually updated the model automatically with the new data, but actually the underlying is to merge the different models. So that's one idea, but we are still working on the algorithm. So far, we still use the big machine to retrain all the data periodically. Yeah.
Yeah, I see. I see a question by Alipio, and I think I can, maybe I can just.
I think you can hear me now.
Oh yeah, perfect. Yeah.
Yeah.
You?
Okay.
My name is Lipio George. Thank you for the great talk. My question is related to cross-language. As far as I understood, the GLM is competing and beating Bert in many tasks. But what about other languages like Portuguese, for example, which is my language? And how can you use GLM in order to apply it to other languages as you do with cross-language, cross-lingual models currently?
Okay, that's a good question. So actually, you can apply this algorithm. I just mentioned that this is a very general pre-training framework. You can apply it to any kind of language. So we have, I could give you two answers. The first one is that you can apply this algorithm to any kind of language and build your own model. And the second one is that in the end of this year, it's very likely we will release a 20-language pre-training model. So which means that we use this algorithm to pre-train Chinese and the English and the Japanese and somehow like a 20 language. We get some kind of text from of 20 language, somehow like that. So you could use that model as well. Okay.
If I may add, I have a question regarding rare languages. I mean, there are some languages for which corpora are really small. And these attention mechanisms and all the components that you're using, they are quite data hungry, as I understand it. Would you see like a limit in the size of the corpora? I mean, Portuguese is still a world language, but there are languages that are much less popular and much less spoken and written.
Oh, yeah. That's a challenge. That's really. There actually are two challenges I have to say. But anyway, here is some kind of comments because for some research actually we are still working on. So the first one is that you somehow to directly answer this question. So the first one is that if some text is, for example, with a lot of data, but some other languages are only limited text. So if we have a lot of data, so actually we can still learn such kind of pattern because, with such kind of algorithm, we can still learn the underlying relationship between them. So for example, even some kind of text, they have so much data, but we can again learn some kind of transformer matrix. That's still good. But some text, if they only have limited text, the performance is still okay. But another challenge actually is much more serious. That is, if we even get all the data, all the data, for example, all the Chinese text, actually we found that the model just overfitting to all the data. The model just overfitting to all the data. Like if you ask any kind of question, the machine just simply find the best answer. The best has some kind of like a quotation. The best answer because the answer is already in that data. So you could say that model cannot really generate new sentences. It can simply just find the existing sentence and answer you. So that's another challenge. That's really challenging. So yeah. Okay, any more questions? Stanford, can I hear you?
Sure, I'm muted, sorry. Thank you, very interesting talk. Have you considered the implications of this work on copyright and detecting machine-generated versus human-generated content? Can you use the same or similar models to certify a text image is machine-generated or not?
Okay, yeah, that's a good question. So yeah, it could be considered as an application. So of this model, but we didn't use it to. But if we are interested, we can provide this model for you to do such kind of application. But again, of course, you actually raised a very good question. So what is the copyright of the data to train such kind of model? Probably that is a real question. So anyway, so far we just opposite. You could consider such kind of pre-training as a transfer learning or federated learning. So somehow we do not have all the data. We only train such kind of model and then use such kind of model to provide some kind of service. So that's the idea. We hope that such kind of model can benefit not just one company or some user, but also we hope that such kind of model can benefit all the people in the world. So that's in the future we hope that this just simply as an AI infrastructure. So we hope that this can avoid the copyright issue. Yeah, thank you.
So okay, the hand by Alipio is no longer raised. So I might have for me final question. It's still a little bit technical. I mean, you're sampling the spans, for different tasks and at different lengths and so on. And you take, my understanding is you adapt or adopt like defaults from other language models, for certain tasks and so on. But can you comment a little bit on the sensitivity of the span length and frequency and so on of this model?
Yes, so I have to say it's not that sensitive. So, but here the point is that, okay, we have to sample some kind of text in the middle or sample some kind of text in the end. And in the middle, of course, it is somehow like a span Bert. The span Bert, the span Bert actually perform better than Bert itself because it actually considers some kind of span, sometimes consider one word and two words or something like that. So it's somehow like the sample from in the middle. So that's a basic idea here. So because in this way, we can actually make this model almost perform similar to the Bert. And in the end, we have to sample like a 50% because in this way, we can learn some kind of model. You could say the generation power similar to the GPT. So if you only sample like a 20% or 10%, so actually it's very limited. The generation power will be limited. So that's the idea. So that's the reason we sample actually in the end we sample almost half, sample more than half, and in the middle we only sample a few words. So that's the idea. But it's not really that sensitive. For example, if you sample like a 10%, or here you sample like a 45 or 6%, it's not really sensitive. In particular, the data size is huge. The parameter size is huge. So yeah, it's really not that sensitive. Yeah.
Excellent. So I think we are out of questions and out of time as far as I can tell. And it was really a great pleasure to listen to your talk and also to discuss with you. I think all of us will agree to this. And yeah, it was a great pleasure and honor to have you here. Thanks for the fantastic talk. And yeah,
thank you. Thank you very much.
Hope next time we meet in person and can chat about your latest progress. All right.
Yeah, definitely. Thank you.
All right. Then thanks to all of you, and enjoy the remaining conference. I mean, it's just we're just halfway through, and there's still other invited talks and community meetings and all that, and of course regular technical talks. So enjoy the day. Thanks again a lot to being here, and bye.
Okay, bye.
Yes, bye.